We're going to start with all inputs low, LED is off. B high, all others low, LED is off. A high, everything else low, LED is on. A and B high, selector low, LED is on. Selector high, everything else low, LED is off. Selector high, B high, LED is on. Selector high, A high, LED is off. All high, LED is on. In order to develop code for number 3, I had to break down what was meant by input A modulating at 10 Hz and input B modulating at 0.5 Hz. Effectively, this means that in 1 second, signal A cycles 10 times, while signal B only cycles 0.5 times, or once every 2 seconds. From this, we can see that signal A cycles 20 times for every 1 cycle of signal B. With these frequencies, we can also determine that each cycle of A takes 1/10 of a second, or 100 milliseconds. Using this logic, I developed the void loop function to correspond to 1 complete cycle of signal B. Within the cycle of signal B, there are 20 complete cycles of signal A, as demonstrated by the inscribed for loop. This for loop completes 20 times, with 1 loop representing a complete cycle of signal A. The delay of 50 milliseconds between output high and low is derived from the 100 milliseconds that signal A takes to complete a full cycle. It's important to note this if statement inside of the for loop. This if statement triggers after 10 iterations of the for loop, marking the halfway point of a complete cycle of void loop. At this halfway point, we must turn off the output at B to create a 50% duty cycle. Here we have the circuit for lab number 3. Right now, the selector switch is set to high, so signal B, the one that modulates once every 2 seconds, is being passed through. If I move this selector wire to ground, you'll see that signal A is now passing through, and the light is blinking at a frequency of 10 Hz.